So let us look at this question. You're asked to find the number of solutions in 0 to 4 pi to the equation 12 cos cube x minus 7 cos square x plus 4 cos x is equal to 9. So this is a similar question to previous type quadratic, but this time we have a cubic. So we follow the same process. We try to factorize this equation. So once we factorize, you get small equations which might be solvable. So first, this is a cubic equation in cos x. That's what your observation is. So let cos x is equal to t. So if cos x is equal to t, you have 12t cube minus 7t square plus 4t minus 9 is equal to 0. So this is a cubic equation. There is no standard process to solve this. So we need to go for trial and error. So we substitute different values for t and see whether they satisfy the equation or not. So in this equation, clearly t is equal to 1 is satisfying this equation. See? So if you put t is equal to 1, so you're getting 12 minus 7 plus 4 minus 9. 16 minus 16 is equal to 0. So t equal to 1 is one of the root of this. That means t minus 1 is a factor for this. So let us find the other factor. So I'll divide this expression with t minus 1. So 12t cube minus 7t square plus 4t minus 9. So if you divide this with t minus 1, you have 12t square. So you have 12t cube minus 12t square minus plus. So you have 5t square plus 4t. So you have plus 5t. So 5t square minus 5t minus plus. So 9t minus 9. So plus 9s are 90 minus 9. We have 0. That means this can be factorized into t minus 1 into 12t square plus 5t plus 9 is equal to 0. So either this is equal to 0 or this is equal to 0. This implies either t is equal to 1 or 12t square plus 5t plus 9 is equal to 0. This is a quadratic equation. This can be directly solved. T is equal to minus b plus minus root of b square minus 4ac, 4 into 12 into 9. That is 4 into 12 is 48 into 9. 48 times 9 is a very large number compared to 25, right? So you have a negative number inside the square root. That means this equation does not have real roots. This quadratic equation does not have real roots. So you have only one solution. T is equal to 1. That means cos x has to be equal to 1. So if this equation has to be valid, cos x has to be equal to 1. So now we are asked to find the number of solutions in 0 to 4 pi. If you draw the quadrant diagram, so for cos, the signs are plus, minus, minus, plus. So cos x is equal to 1 when x is equal to 0, right? So this is the position corresponding to cos x is equal to 1. So if you go from close 0, so you have one solution in one rotation. And if you're going for other rotation, you have crossed this position 2 times at 0, 2 pi and next at 4 pi, but you have open 4 pi. So you cannot consider 4 pi as the answer. So obviously, as you can see, cos x is equal to 1 only at this position. So between 0 to 4 pi, you come to this position 2 times at 0 and 2 pi. So the answer is equal to 2. Number of solutions in close 0 to 4 pi is equal to 2. So I hope you have understood this concept of factorization. And this will be used if you have a higher degree trigonometric equation. So in this question, you're asked to solve this equation. 3 tan 2x minus 4 tan 3x is equal to tan square 3x into tan 2x. So if you observe this equation, you have tan 2x and 3x. This equation is made up of tan 2x and tan 3x. Now, so how do we analyze this? What I try to do is I'll try to factorize this equation. So 3 tan 2x. What I'll do is I'll separate 3 tan 3x and minus tan 3x. Minus 4 tan 3x can be written as minus 3 tan 3x again minus tan 3x is equal to tan square of 3x into tan of 2x. So this implies 3 times, if you take 3 as common, you have tan 2x minus tan 3x is equal to, so if you send minus tan 3x onto that side, you get plus tan 3x. So you have tan 3x in both the terms. So if you take tan 3x as common, you have 1 remaining here plus tan 2x into tan 3x. So this implies, so do you remember some formula? You have tan 2x minus tan 3x here, 1 plus tan 2x tan 3x here. I'll bring this to the denominator and I'll send this here. So 3 times tan 2x minus tan 3x by 1 plus tan 2x tan 3x is equal to tan 3x. Now what is this a formula for? Tan A minus tan B by 1 plus tan A tan B is tan of A minus B. So 3 times tan of 2x minus 3x is tan of minus x is equal to tan 3x. So this implies minus 3 tan x is equal to tan of 3x. So this implies if you send minus 3 tan x onto that side, you get plus 3 tan x plus tan 3x is, what is the formula for tan 3x? 3 tan x minus tan cube x by 1 minus 3 tan square x is equal to 0. So you have tan x in each of this term if you take tan x as common. So you have tan x times 3 plus if you take tan x as common from this. So you have 3 minus tan square x by 1 minus 3 tan square x is equal to 0. So if you take LCM, so tan x times 3 minus 9 tan square x plus 3 minus tan square x by 1 minus 3 tan square x is equal to 0. If you take the LCM, this becomes equal to 0. So you have tan x times 6 minus 10 tan square x is equal to 0. This implies tan x is equal to 0 or tan square x is equal to 6 by 10, that is equal to 3 by 5. So tan x is equal to 0 or tan square x is equal to 3 by 5. So this implies x is equal to n pi. So tan x is equal to 0. 0 can be written as tan 0. So you have x is equal to n pi, or tan square x is equal to 3 by 5. The solution is n pi or m pi plus or minus some angle alpha such that tan x is equal to root of 3 by 5. Such that alpha is some angle such that tan alpha is equal to root of 3 by 5. So you have these two as the solutions to this equation. So what we have done in this question is we have tried to factorize these equations and take some terms as common and form a quadratic, and I have solved the quadratic. So let us look at this question. Sin 2x plus cos x is equal to 0. How do I solve this? So let me solve this in two different ways. So the first is the method of factorization. So can I factorize this? Can I divide this into two factors? To do that, what I do is sin 2x, you know that it is 2 sin x cos x plus cos x is equal to 0. So you have cos x here as well as here. So cos x, if I take it as common, I get 2 sin x plus 1 is equal to 0. So this implies something into something is equal to 0, implies either cos x is equal to 0 or 2 sin x plus 1 is equal to 0. So cos x is equal to 0 or 2 sin x plus 1 is equal to 0. This implies what is the general solution of cos x is equal to 0? We've already derived this. So the odd multiples of pi by 2 satisfy this equation. So x is equal to 2n plus 1 times pi by 2 odd multiples, or sin x is equal to minus half. So correspond to minus half, what is the angle that you get? So I can take minus half as sine of minus pi by 6, right, in the fourth quadrant. So sin x is equal to sine of minus pi by 6. So x is equal to n pi plus minus 1 whole power n times pi by 6 with a minus sign. So minus sign can be included into minus 1 and the power can be written as n plus 1. So minus of 1 again. So minus 1 into minus 1 whole power n is minus 1 whole power n plus 1. So the solution is either this or this. So if you're asked to find the number of principal solutions, so you have pi by 2 and 3 pi by 2 as the principal solutions here. Pi by 2 and 3 pi by 2. And here, if you put n is equal to 0, n is equal to 0, you're getting minus pi by 6. That cannot be considered. Start with n is equal to 1. So you have pi plus pi by 6. That is 7 pi by 6 is okay. And if you put n is equal to 2, 2 pi minus pi by 6. 2 and the power becomes 3. So 2 pi minus pi by 6. That is 11 pi by 6. So these are the two principal solutions for this side. These are the two principal solutions for this side. So in total you have 4 principal solutions for this equation. So this is one way of doing this. This method is called factorization method. So the other way to do this is, so how we can do this is sine 2x is equal to, so this cos x, if it goes onto that side, it become minus cos x. So can minus cos x be written as sine of something? So this can be written as, minus cos x can be written as something like sine of, can I write it as 3 pi by 2, because if sine has to be equal to minus cos x, sine has to be converted to cos, so this number has to be odd and you have to get a minus also. So I'll go for 3 pi by 2 minus x. So what is sine of 3 pi by 2 minus x? The quadrant is third quadrant, sine is negative, you get a minus, and the number is odd, so sine converts into cos, so you get minus cos x. So you can also put plus here, the same thing will come. So sine 2x is equal to sine of 3 pi by 2 minus x. So this implies sine of something is equal to sine of something. So I can write this as 3 pi by 2 minus x is equal to n pi plus minus 1 whole power n times 2x, right? Something has to be equal to n pi plus minus 1 whole power n times something. So I can write the reverse also, it doesn't really matter. So this is a solution for our equation. So let us try to analyze our solution. Because x is there here as well as here. I want to bring x onto one side. So first what I do is minus 1 whole power n depends on whether n is even or odd. So first I will take two cases. Case 1, let n be equal to an even number 2m. If n is equal to a number of the form 2m, what happens? So 3 pi by 2 minus x is equal to 2m pi. If n is of the form 2m, minus 1 whole power 2m will be plus 1. So you get plus 2x. So this implies if x goes onto that side, 3x is equal to minus 2m pi plus 3 pi by 2. Minus 2m pi plus 3 pi by 2. So this minus 2m can be written as plus 2m, doesn't really matter, because m is an integer. M takes positive values as well as negative values. So if you can take this minus to m, minus m is also an integer. So this is of the form 2m pi plus 3 pi by 2. So this implies x is equal to, if you bring this 3 onto this side, 2m pi by 3 plus pi by 2. This is one solution to the equation. The case 2, if n is of the form 2m plus 1, it is an odd number. Now what happens is 3 pi by 2 minus x is equal to 2m plus 1 times pi. This minus 1 whole power odd number becomes minus 1. So you get minus 2x here. This minus 2x goes onto that side. So plus 2x minus x is equal to 2m plus 1 times pi minus 3 pi by 2. So the solution of x is either this or this. So as you can see, it looks quite different from the general solution of The same question obtained from the different process. But the final answers in the roster form will be same. There can be more than one different form to express a solution set builder form. We have seen that in the topic of sets. So these solution on the face value might look different, but if you expand them, we expect the same answers. For example, let us expand this. Let us find the principal solutions. Let us see whether you're getting the same positions or not. So what are the principal solutions for this? So put m is equal to 0, you're getting pi by 2. Put m is equal to 1, you are getting 2 pi by 3 plus pi by 2. 2 pi by 3 plus pi by 2, that is 4 pi plus 3 pi, 7 pi by 6. So put m is equal to for 0 you got pi by 2, for 1 you got 7 pi by 6. If you put m is equal to 2, 4 pi by 3 plus pi by 2, you're getting 8 pi plus 3 pi, that is 11 pi by 6. You're getting 11 pi by 6. Next, if you put m is equal to something like 3, so you're getting 2 pi plus pi by 2, you're going beyond 2 pi. So these are the three principal solutions from this side. So if you go to this side, put m is equal to 0. Pi minus 3 pi by 2 is a negative number. M is equal to 1. M is equal to 1. 3 pi minus 3 pi by 2 is 3 pi by 2. So you're getting 3 pi by 2 from this. Put m is equal to 2. 5 pi minus 3 pi by 2. 5 pi minus 3 pi by 2 is 10 minus 3. 7 pi by 2 is going beyond 2 pi. So this cannot be considered as a principal solution. So all the three positions, this position, and this position are being covered by this set builder form, and only this position is being covered by this. So effectively you're getting the same positions. The answers might look different, but once you expand this solutions in the roster form, they look same. So I hope you have understood why you're getting two different answers to the same question. So again, you might get two different answers, but what you need to check is once you expand them in roster form, you need to get the same numbers. Then both of them are correct. Thank you.